So now let us see some of the graphs, some important graphs. Suppose if let us first study the uniform motion. Uniform motion. We know that in uniform motion, the velocity is constant, right? So if I draw the position time graph, okay, position time graph. So what is the nature? Suppose a particle is moving straight line. It can be any line like this. It can be like this. It can be like this, right? It has to be a straight line. Okay, so if I draw velocity time graph, what is the nature? Okay, and what about the acceleration time graph? Yes, so it will be constant. It will coincide with the time axis, right? Yes. Clear? Okay. Yes. So now if we have uniform accelerated motion, uniform accelerated motion, it means your acceleration is constant. Clear? So if I draw, say, position time graph. So first of all, let me give the graph of v versus t, right? It will be something like this. Okay. Any line, right? And if we draw acceleration versus time graph parallel to the time axis, right? Something like this. Or if there is, if we have a deceleration, so it will be below, right? Below the time axis. Now, do you know this formula S is equals to ut plus half at square? Yeah. So you can see that your displacement, it's a function, it's a parabolic function. Can you see that? So the graph will be parabolic, right? So it can be like this, right? Your graph can be like this. It has to be a parabola. It can be upward parabola or it can be a downward parabola. Okay. So now when we have, say, y equals to, say, ax square plus bx plus c, if a is greater than 0, right? If a is greater than 0, then we have an upward parabola, right? If a is less than 0, in that case, we have a downward parabola. So the coefficient of x square will tell us what is the nature of the graph, right? Okay. So now, suppose there is a car. Let us consider the same case. So let us consider this case. There is a car which accelerates, right? Which accelerates with a rate alpha for some time, and then it decelerates, right? With beta and comes to rest. So it starts from A and it again comes to rest at C, right? Okay, so this time let us say is T1 and this time duration is T2, right? Now we have to draw what is the position time graph or displacement time graph, right? So if I show you, say this is our X and this is time, right? We know that from A to B, the particle is accelerating from rest. So, and let us say the particle starts from origin, right? Say this is X equals to 0. So it will be a parabolic curve, right? And its acceleration is positive, or you can say the velocity is increasing, right? So it will be something like this, right? Say this point, we have come to this particular point. Let us say this is T1, right? Now after that, the particle is decelerating. Now the particle is decelerating, right? Now you can see the slope. The slope of position time graph will gives you the velocity at different times, right? So let me show you. So if I draw the slope, at this particular point, the slope is like this, right? At this point, the slope is like this. You can see the slope is increasing, right? If slope is increasing, it means your velocity is increasing. In the second part, from B to C, the particle is decelerating, so the slope should decrease, right? So the nature will be something like this. It will be something like this. Got it? And at this particular point, the slope should be parallel to the time axis because velocity is 0. At the initial position and at the final position, the tangent will be something like this. And this particular point will be your T1 plus T2. So now you can see that whenever we have, say, acceleration in that case, the graph will be something like this. And whenever the particle is decelerating, right, it will be something like this. This is your upward parabola. This is your downward parabola. Portion of that, right? If the particle keeps suppose after C, still the particle have the same acceleration beta, right? In that case, it will further go in the position will decrease and it will go something like this. This one is your down, yes, downward parabola, and this is a upward parabola.
Okay.
Which is open from the upward side, right? Suppose if we have this case, let me take one more case. So we have given velocity time graph. You can see that from 0 to 5 seconds, the particle is accelerating, right? And from 5 to 10 seconds, the graph is flat. So it means the velocity is constant. So we have a uniform motion. And from 10 to 12, the particle is decelerating, right? Okay, so now we have to draw the displacement time and the acceleration time graph. So let us first draw the acceleration time graph. So what is the acceleration? Acceleration is defined as dv by dt, right? Now from 0 to 5, you can see that the slope of velocity time graph will be your acceleration. So at every point between 0 to 5, the slope is same, right? Because it's a straight line.
Yes.
So let us find the slope of this line. So what is the slope of this line? From say this point is A, this point is B, this point is C, and this point is D. So AB line, what is the slope of this line? Perpendicular upon base, right? So your acceleration from A to B is 2 meters per second square, right? What is the deceleration from C to D? Yes, minus 5 meters per second square. Clear? And your velocity from B to C is 10, right? Okay, so now we know the time for which the particle is accelerating. Particle starts from rest. So let us first draw the, let us draw the acceleration time graph, right? So we have acceleration. This is time. So from 0 to 5, so this is your 5. Acceleration is constant up to 5, right? So it will be this, right? Let me show it at this point, right? So this is your 2 meters per second square. Clear? Now from 5 to 10, what is the acceleration? So it will be constant with the time axis. Okay. Now from 10 to 12, what is the acceleration? Minus 5, right? So your graph will be
down
below time axis somewhere, right? And this point will be minus 5 meters per second square. Clear? Now this is your acceleration time graph. Now let us draw your displacement time graph. So this is your position and this is your time from A to B. So what is the displacement? So you can that will be area under the curve, right? So from 0 to 5, the area will be what? It will be half into base into height, right? 25 meter. So let us say this particular mark is 25 meter, right? And this time is 5. So the graph will be something like this. It will accelerate, parabolic graph, right? This is the, okay. So from 0 to 5, this is the graph of position time, right? Now from 5 to 10, it is moving uniformly, 50. Right? It is, yes. So it will be 10 into 5, that will be 50. So it comes out to be, the position will become 70, 75, right? Okay. Now your graph will be a straight line. Why straight line? Because it's a uniform motion. It's a uniform motion, and the in uniform motion, the particle cover equal distance in equal interval of time. So it should be a straight line. Now at this particular, this is your 10, right? Clear? Now from C to D, the particle is decelerating, right? So what is this area? 10, right?
Yes.
It will be 10 meters. So now it will further goes in the X direction. So it will become 85, right? So the graph will be like this. And it comes to rest. Clear? Now this particular mark will be your 12 seconds. I hope now you know how to draw the graph, right? If the velocity time is given, you can draw the graph of position time or displacement time. Now, in this case, displacement time graph or the distance time graph will be same, right? That is the same graph. Position, if they ask position time, distance time, right? It is the same graph. Now, if you suppose the particle changes its direction, it goes further. If I show you that it goes further in this direction, right? And this is your 14 second, right? If it is like this, in that case, at this particular mark, what will be the velocity? That will be minus 10, right? if suppose the particle further continue with its motion, and now its velocity is reversed, and it will having an acceleration of 5 meter per second square, right? Beyond d, right? So
yes.
so as you can see, this is 14 seconds, this is 10 seconds, so acceleration is same. So this particular mark will be minus 10 only, right? Because this is plus 10, right? Now the displacement in this, the area of this triangle will be same as 10, right? Let me draw the graph again, right? Say if I have something like this. Got it? Right? This is 10, this is 12, and this is 14, right? By symmetry, you can see that no, like these 2 points are symmetrical. So if this height is 10, this also be 10, right? Okay, because this base of the triangle is same. This is 2 and this is also 2, right? And this angle is same as this angle, so this has to be 10, right?